Hi, everyone. Welcome back. Okay, so today's lesson is going to be a little bit different. It's something I'm adding into the lessons. It is from Module 2, Topic 1. It is Lesson 5. It's kind of coincidental that this is called Unit 1, Lesson 5. So it's Module 2, Topic 1, Lesson 5. Let's see if I can get this to focus. Okay. So graphing ratios from tables. So we've been working on ratios in class, and now today we're going to move forward to graphing these um, on a graph here. So let's start here at the top. Vocabulary, ordered pair. A pair of coordinates written with parentheses, always in the form of x comma y. Now I know you guys did ordered pairs last year as fifth graders. In fact, if you look as you're walking down the hall right now, this year's fifth graders have some ordered pair pictures kind of hanging up on the wall on the bulletin board across from Mrs. Pulver's room. So you can check that out. Keywords and phrases to look for in recognizing ratios. To, for every, for each, and out of every. We've been over those. A ratio table, equation, or double number line can be used to create ordered pairs. These blank blank can then be graphed on a coordinate plane to represent the ratio relationship, and that's ordered pairs. So we have an example here. It says, school t-shirts are $10 for one. Use this information to fill in the table below. So in class, I had talked about when we did lesson 4 that we were going to turn our table vertically instead of going horizontally like it did in lesson 4. So this is what I was talking about. So here we go. So it says $10 for one t-shirt. So for one t-shirt, the cost is $10. So then how much is it for two t-shirts? All right, $20. So this one's fairly easy, and you can probably pretty quickly just go through and fill that out because you know that $10 times each number of t-shirts, if T means t-shirt, equals the cost. So T equals t-shirt. It's really the number of t-shirts, and C is cost, the cost for them. Okay, so then it creates an ordered pair. If we think about this alphabetically, X comma Y, we then have the ordered pair 1 comma 10, 220, 330, and 4 comma 40. Okay, so then when we graph those, you guys should remember from last year, you plot the X coordinate first. So remember, it is alphabetical, so it's X comma Y. So the X is this axis. This one is the Y. I like kind of doing that for the Y. It's kind of like instead of a Y just stopping there, if you just make it go straight, that helps you remember that this is the Y. So this is the X. So for the ordered pair 110, it means go over to 1 on the x-axis and go up to 10 on the y. We're going to put a dot. And then for the ordered pair 220, we're going to go over to 2 on the x, up to 20 on the y, 330 over to 3 up to 30, 440 over to 4 up to 40. Okay, and that's all we have to graph from there, but we have a lot of information we can kind of say about this graph. I should have found my ruler before I started the video. I'm just going to use an index card. Okay. So if I kind of line up a straight edge here and I connect my dots, it's fairly decently drawn. I can then answer a lot of questions about the t-shirts without having to continue a table. So for example, if I said 7 shirts without doing a table, you could go over to the 7 and go up to 70, and you can see where it's plotted. You know, at 70, let me kind of back that up. You know, at 70 because when you go over to 7 and you go up to the line, it crosses right here. So this is 70. Let's try another one. So what about at let's say 90? Let's say maybe we ask it differently. If using 90, if the cost is $90, how many t-shirts can that buy? So if we go to 90 and we follow 90 across to where we hit the line, and then we can follow that back down, we see it's 9. Your book kind of shows some dotted lines on each. I'm not really a big fan of that because then there's a lot of information going on. I do like kind of putting an index card. Let me kind of color in the edge of this. That's white, kind of blends into the paper. You can do this with your index card as well. So here where 90 goes across, and I'm going to put that corner right where it touches the line, keeping it there. Sorry, this is a Post-it type of index card and it gets stuck. To peel it off. And then if we come down, we see it crosses at the 9. Okay, let's move on to the next one on the back side of this page. To make cotton candy, you spin flavored sugar in warm air. You need to use 2 cups of sugar mixture for each cotton candy cone. Complete the table below, then use the graph to represent the relationship. Okay, so cotton candy says you use 2 cups of sugar mixture for each cotton candy cone. So 2 cups of sugar. So then the ordered pair is 1, 2. Notice this is our X, this is our Y, and in the ordered pair form, it's the X and Y. Our X is here, which matches with the cotton candy cones. The Y is right here, the cups of sugar, and it matches with the label here. Okay, so if one cotton candy uses 2 cups of sugar, then 2 batches of the cotton candy need how much sugar? Well, how do you go from 1 to 2? You times 2. So 2, if we're thinking about it this way, 2 times 2 is going to give us 4. Right? We're increasing here by times 2. So what about 3? How do you go from 1 to 3? You do a times 3. So from here to here then, we still need a times 3. So 2 times 3 is going to be 6. We'll fill out the ordered pairs here in a moment. I'm going to switch colors. So for cotton candies, again, you can start at the 1. It's always easy when you're multiplying by 1. So 1 times 4 gets us to the 4. So 2 times 4 gets us, it equals 8. And then lastly, for 5, we would have 1 times 5 for a product of 5. And then on this side, we need to do 2 times 5, which equals 10. Okay, now we need to plot them. That's right there, ordered pairs. So we have 2, comma 4, 3, comma 6, 4, comma 8, 5, comma 10. So remember, we are going over first on the x-axis, then up to plot the y value. So we are going over to 1 on the cotton candies because it's the x, and then up to 2 on the cups of sugar. So over to 1, up to 2. Next one is over to 2, up to 4. And we have 3, 6, 4, 8, and over to 5, up to 10. Again, we can then use a straight edge. We're going to make it go through the 0, 0 is called, it has a special name. I don't know if you guys did it last year. I'm assuming you did. It's called the origin. It's where 0, 0 is located. So we're going to make sure our line goes through the origin here for this one, because when it's at a constant rate of change, and we don't have any prior conditions kind of starting things, which I'll explain that on another video, it'll go through the origin. Because when there's 0 cotton candies, we don't need any sugar. So 0, 0 makes sense. All right. No sugar means no cotton candy cones. So in recipes, you can oftentimes do half a batch. So using the graph, if we were going to have 2.5 batches of the cotton candy cones, how much sugar would we need? So if we go over to 2.5, which is here, and then we follow that 2.5 up to where it crosses, it meets the line. It would be right here. And then we follow that across, it would be 5. We would need 5 cups of sugar. Does that make sense? Does that fit in between 2 and 3? Halfway between is 2.5. Halfway between the 4 and the 6 would be 5. So yes, it makes sense. Okay, I think I'm going to do one more here with you. All right, Sally spends her weekends making cookies to sell. For each dozen, she charges $15. Complete the table below and graph the ratios on the coordinate plane. So 1 dozen is $15. So 115. So 2 dozen would then be, we're going to do a times 2 and a times 2, so it would be $30. So 2 and 30. What about 4? We don't assume you're just going up by 15s because we miss a number here. So how do you go from 1 to 4? Times 4. So what's 15 times 4? Right, so it's 60. 460. I do want to point out, if you think about 2 dozen cookies, if we started at the 2, we could say we go from here to here by a times 2. Right, so if we started here, 2 times 2 gives us 4, and 30 times 2 gives us the 60. So it doesn't matter where you start on your table, as long as the number you're scaling up by, you do with both values in that same part of the table. So for example, I can't do a times 4 from here to here and then go here and do a times 4 to get to here. You would have to start with the 15. Okay, and then the 6. So 1 times 6, and then 15 times 6. So that's going to get me 90. So we have 6, comma 90. I do want to point out just a little side note. You don't have to highlight this, but we talked about when we can add within the table. And I do want to point out 2 plus 4 gives me 6. The corresponding values for the 2 and the 4 are 30 and 60. And when I add those together, I get the 90. Okay, so let's plot this. So 115. So go over to the 1, up to the 15. Remember, this is your X, this is your Y. In your ordered pairs, the X always comes first. Ordered pair 230, so 2 dozen cookies cost $30. 4 dozen is $60. 6 dozen is $90. So over to the 6, up to the 90, and put a dot. Now let's connect our dots. I put an arrow on the end because this would keep going on and on and on. So then we have a question with this one. How many dozen cookies will Sally need to sell to bring in $240? So I don't see 240 on here. So we're actually going to come back to that one in a moment because this one we can answer with our graph. How much money will Sally bring in if she bakes 9 dozen cookies? So here's the 9 dozen. So if we line this up, it hits that line right there, which matches with $135. So $135. So we can set up a ratio to solve this. This part here, I'm not really concerned about right now. If D is dozen of cookies, every dozen is $15. So we can take our total number of dozens and multiply it by 15 to get our cost. Right now, we're being given the cost. So let's just set up a ratio instead. Let's see. So we have $240. I think I want to use this 4 and 60. 4 dozen is $60. So how many dozen is $240? How do I go from 60 to 240? Times 4. So here I need to do a times 4. So we should get 16. And maybe you did it a different way. I would be interested in knowing if anybody thinks about it differently. I could do this 15 times the number of dozen equals 240. So then I'm thinking 15 times what is 240? I can use the inverse and do 240 divided by 15, and I should get the number of dozen would be 16. I can use any of the other ratio numbers as well. Let's say we're using 2 and 30, and then we know it's 240. How do you go from 30 to 240? That would be a times 8. So here is a times 8. 2 times 8 gives us 16. So notice we get the same answer here. If our graph went out to 16 dozen, we would see that it would go up to $240. So it would be somewhere up in here. Okay, excellent. I'm going to have kids in class do this page independently, and then we're going to join back together and see how you did. So this is the next page in it. I want you to pause the video. I'm going to pause it now, and then we're going to come back and check on this.